In this section, we're going to do complex fractions and rationalizing. Okay, and as an example, we want to simplify this nasty looking expression. Okay, and notice it has numerators and numerators, it has denominators and numerators, it has numerators and denominators, and it has denominators and denominators. It's crazy, right? So what we want to do to simplify this is to get rid of all the denominators in the numerator and the denominators in the denominator. So we want to eliminate them. Now, what we don't want to change the value of the expression itself. So we're going to multiply it by 1, but it's going to be a fancy form of 1. Okay, it's going to be a form of 1 that cancels out all the denominators in the numerator and in the denominator. Okay, now, so what we need is a common denominator of 4, 3x, and 2. All right, now, the foolproof way of finding a common denominator is just by multiplying all the denominators together. It might not be the least common denominator, but doesn't matter. It will be a common denominator, okay? And so we're just going to multiply them all together to get 4 times 3 times x times 2, which is equal to 24x, okay? And so we're going to multiply top and bottom by 24x. And 24x over 24x is just 1. So once again, we're not going to, because we're multiplying this expression by 1, we're not going to change it. We're just going to put it into a different form. Okay, all right, so let's work on the numerator first. So 24x multiplied by x squared over 4. Okay, and the x squared times the x is x cubed, and then 24 over 4 is 6. So that becomes 6x cubed. Okay, now let's multiply 24x by x over 3. All right, x times x is x squared, 24 over 3 is 8, and so what we get is plus 8x squared. Okay. All right, now let's go down here. 24x times 4 over x. The x's cancel out, okay, and 4 times 24 is 96. So that becomes 96. And then multiplying the 24x by 3 halves, the x is just x, it comes along. And then 3 halves times 24, 3 times 24 is 48, divided by 2 is 24. And so that becomes plus, oh, sorry, 3 times 4 is 72, my bad. And then 72 divided by 2 is 36, so we get 36x. Okay? All right, now we need to simplify this. Now, just looking at the numerator, I can factor out a 2 and an x squared, or I'll just factor out a 2 for now. So I can factor out a 2 there. Notice I can also factor out a 2 in the denominator. Okay, so those two 2's can cancel out. All right. Now, if we had multiplied by the least common denominator, which turns out to be 12x over 12x, we wouldn't have had to do this step. But that's okay. It's an easy step to do. Just factor out the common factors and cancel them out. So what we're left with then is 3x cubed plus 4x squared over 48 plus 18x. And we can simplify that a little bit by factoring out an x squared from the top and a 6 from the bottom. And so that's what we get. In the simplest form, we get that. Okay, so let's review what we did. We started with this nasty looking expression, and we want to get rid of the denominators, okay? And so we multiply by a value that will eliminate all the denominators. But we have to do the same top and bottom because we can't change the form, so we got to multiply by a fancy form of 1, right? So that's where we got 24x over 24x, and then multiply each to get that, and then simplify down, boil it down to this right here. Okay, that's example number 1. Example number 2. I want to simplify this expression. Once again, we're going to multiply. We don't want to change it, so we're going to multiply by 1. But it's going to be a special form of 1 once again, and it's going to be the common denominator over itself. So the common denominator can be found by multiplying them all together. And 5 times 4 times x squared times x is 20x cubed. So we're going to multiply top and bottom by 20x cubed. Okay, and then we're going to do each one in turn. So first of all, let's multiply 20x cubed times x over 5. X times x cubed is x to the 4th, and then 20 over 5 is 4, so we get 4x to the 4th. Minus 20x cubed times 3/4. X cubed just comes along for the ride, and then 3 times 20 is 60, divided by 4 is 15. So we get 4x to the 4th minus 15x cubed. All right, now let's work on the bottom. let's do 20x cubed times 16 over x squared. Okay, now x cubed over x squared is just x, and then 16 times 20 is 320. So we get 320x plus 3 over x times 20x cubed. Okay, and x cubed over x is x squared, and 3 times 20 is 60. So we get plus 60x squared. Okay, and now all the denominators are gone. We can simplify this a little bit further by factoring out an x cubed from the numerator, okay, and a 20x from the denominator, okay, and this is what we get. Okay, once we factor those out, and then I can simplify this yet further by noticing there's an x cubed in the numerator and an x in the denominator. This x will cancel out one of them in the numerator, and what we have is this: x squared times quantity 4x minus 15 over 20 times quantity 16 plus 3x. And that is as far as we can take it. I suppose you could turn this expression around and write that as 3x plus 16 if you wish. You don't need to, but you could. It wouldn't make any difference at all. All right, so this is our answer here. Okay, now let's simplify this. All right, so I'm going to multiply it by fancy form of 1. And the common denominator in this case will just be 9 times the quantity y plus 4. Okay, that will cancel out top and bottom. All right, now let's, the first one, 9 times quantity y plus 4 times 2. The y plus 4s will cancel themselves out. And I'm just left with 2 times 9, which is 18. Minus 2y over 9 times this. Now, the 9s are going to cancel out this time. Okay, and we'll be left with 2y times the quantity y plus 4. In the denominator, multiplying the first term by 9 quantity y plus 4, the 9s are going to cancel themselves out. And we'll be left with, what's left is y times the quantity y plus 4 minus 4 over y plus 4 times this. The y plus 4's cancel out in this case. Okay, and what's left is 4 times 9, which is 36. So this will be minus 36. All right, so multiply each of them in turn. Now, we can simplify numerator. We can distribute the 2y through the parentheses in the numerator. We can distribute the y through the parentheses in the denominator. So the numerator becomes 18 minus 2y squared minus 8y, and the denominator becomes y squared plus 4y minus 36. Okay, now I'm going to rearrange that a little bit to be negative 2y squared minus 8y plus 18 and y squared plus 4y minus 36. Okay. Okay. Now let's do this one. Okay, now we can simplify this by multiplying by a denominator, by multiplying by a value that will cancel out all the denominators. Now we only have a denominator of x plus 1 here. So I can just multiply by x plus 1 over x plus 1. Multiplying the first term, okay, x over x plus 1 times x plus 1. The x plus 1's cancel themselves out, and all I'm left with is x. Plus 1 times x plus 1. Well, 1 times anything is itself, so I'm just going to put plus x plus 1. Note, I surrounded the x plus 1 with parentheses. You should do that just in case it's important. All right, let's go to the denominator, and the first one, as in the numerator, that just becomes x, and then minus the x plus 1. Okay, and notice I surrounded them in parentheses just in case it's important, and it is in this case. In the numerator, since we're adding, we can just ignore the parentheses, and that's just going to be x plus 1. But if you have minus a quantity, you have to carry that negative 1 through, distribute the negative 1. And so that becomes x minus 1. Okay, so be careful about that. All right, let's go back up here. When we're multiplying x plus 1 times a negative 1, you have to surround the x plus 1 in parentheses because we're going to end up having to distribute that negative 1 through. Okay, be careful about that. That's an easy mistake to make, so watch for it. All right, well now we can just simplify top and bottom. X plus 1 is just 2x plus 1, and the denominator just becomes negative 1. which we can simplify a little bit further to call this, change the signs in the numerator, and negative 2x minus 1 is your answer. Next, let's do example 5. Now note the denominators here. We have x minus 5 there, we have 4 there, we have x there, and we really just have 1 there. So we just focus on these 3. So when I multiply by my special form of 1 now, I'm going to cover all those bases. I'm going to cover the 4, the x, and the x minus 5 quantities. So we're going to multiply top and bottom by this. Okay. Okay, now let's multiply them in turn. So we're going to multiply this 4x quantity x minus 5 times the first term here. Now x minus 5 is going to cancel out. So literally cover up x minus 5 here with your finger, cover up that with your pencil or whatever. And what's left over is the 2, the 4, and the x, which multiplied together becomes 8x. All right, now for the second one, 3 times that, well, there's no denominator to cancel out, so it's just going to be 3 times 4 times that stuff. All right. Now for the denominator, x over 4 times this, the 4 is going to cancel out. So literally cover up the 4's, with your finger or pencil. And what's left over? You have the x there, you have x there, and you have an x minus 5 there. Okay. Minus 3 over x times that. Okay, what cancels out here? The x's. So literally cover them up, and what's left over? We have the 3, the 4, and the quantity x minus 5. All right, so we're going to get to that point. You got to be careful with that step. I literally just cover them up with my finger and pencil and see what's left over. All right, so now we're to here, and now we can kind of simplify. So 8x is just going to stay. And then 3 times 4 is 12 times x is 12x, and then distribute the 12x through the parentheses, and we get 12x squared minus 60x. That's for the numerator. For the denominator, x times x is x squared, and distributing the x squared through the parentheses, we get x cubed minus 5x squared. And then for the second term, 3 times 4 is 12, which we distribute through that, and we get 12x plus 60. Okay. All right. And then we can combine like terms in the numerator. All right. And so that becomes 12x squared minus 52x in the numerator. And then we could factor this a little bit just to simplify it. Just one more step. We'll pull out a common factor of 4 and an x from the numerator, and then we'll leave it like that. Okay. I have a notion that the denominator is factorable too, but I think we'll just leave it at that. In fact, I would accept either answer. All right. Just to get to this point means that you know what you're doing. All right. All right, next. Now, this is a different type of simplification, and you can see that by the fact that there's a radical in the denominator. Okay, now, radicals in the denominators are kind of special. We deal with them in a special way. So out in the margin, I'm just going to do before we do this one, I'm going to do something else. So let's say we're going to simplify 2 over root 3. Now, we just don't like to have radicals in denominators, so the way to get rid of that is to multiply by another special form of 1, root 3 over root 3. Because when we multiply that, the denominators become just 3. Root 3 times root 3 is 3, and the numerator is just going to stay like that. So now the radical is out of the denominator. So we don't like to have radicals in the denominators. To simplify something like this, just multiply by the radical in the denominator, and it eventually goes away. This is a little bit different, okay, because we have 2 terms here. They have a 3 and you have a root w. So you can't just multiply top and bottom by root w. Instead, you have to multiply by something called the conjugate of the denominator. And the conjugate is the same 2 terms, but the opposite sign between them. Okay, so the conjugate of 3 plus root w is going to be 3 minus root w. All right, so let's multiply top and bottom by 3 minus root w. Okay, now when we do that, the numerator is just going to be quantity w plus 2 times quantity 3 minus root w. That just stays the same. But watch what happens in the denominator. Okay. by operating FOIL on this thing, first, 3 times 3, outer, okay, oh, actually, that's right there, inner, that's right there, and then last, root W times root W is equal to W. And then notice that the radical terms add to 0. They're opposites. So while the numerator stays the same, it's okay to have a radical in the numerator, no big deal. But the denominator simplifies to just 9 minus W. And that's our answer. So by multiplying by the conjugate, it eliminates the radical from the denominator. Now, I'm going to do this again, but I'm going to kind of take a shortcut. Okay, I'm going to illustrate a shortcut. And the shortcut takes advantage of this property of binomials, where quantity a minus b times quantity a plus b goes to a squared minus b squared. Okay, the inner and outer terms cancel out. Negative ab, positive ab, they cancel themselves out, right? And so we take advantage of that fact. So if we have a plus b, a minus b, what we're just going to do is to square the first term. So 3 times 3 is 9. Minus, okay, minus, and then square the last term. Root w times root w becomes w. All right, and we can get there directly without actually having to do FOIL. Square the first term, square the second term. And so multiplying by the conjugate removes the radical term. Okay? And we can just do it that way. And it's just a bit of a shortcut. You can do it by FOIL if you wish, but you can also take that little shortcut. Now let's simplify this. Now, look, I have a root term there and then a minus 7. The conjugate of this is going to be the same two terms, but the opposite sign. So instead of minus, it's going to be plus. And so let's multiply top and bottom by the conjugate. Okay? What we get in the numerator is just that quantity times that quantity. We just leave it like that. We don't multiply it out. We just leave it like that because this is actually the simplest form. Okay? But the denominator, we're going to take the first term squared, and root a plus 5 plus root a plus 5 is just a plus 5. Minus, remember that has to be a minus, and then the second term squared. So 7 squared. Okay? And we're basically done, except we can simplify the denominator a little bit, and it'll become that for our answer. Okay, so quick and easy, right? So multiply top and bottom by the conjugate, and the radicals in the denominator go away. One more example to do. Let's simplify this expression. Now you got to be careful with the conjugate of root x minus root x plus 1 is going to be the first one and the second one, but we're going to take the opposite sign. Okay, just take the opposite sign. And so we're going to multiply top and bottom by that conjugate. The numerator just becomes that quantity times that quantity. We're not going to change that. Okay, but the denominator, we square the first term minus, and we square the second term. Okay. Now, be careful here. We have x minus a quantity. So when we simplify the denominator, we have to carry that negative 1, distribute the negative 1 through the parentheses. So the denominator becomes x minus 1. Okay, which we can simplify a little bit further. X minus x goes away, and so we just have a negative 1 out there. And I'm just going to get rid of that denominator by taking that negative 1 up to the numerator. And I'm just going to leave it like that. So that's how we simplify these complex rational expressions. Okay, a couple of different ways. For the first part of this, we got rid of the denominators by multiplying top and bottom by a special form of 1. And the other type of simplification is if you have a radical in the denominator, then you multiply by the conjugate. And by multiplying by the conjugate, it eliminates the radical in the denominator. Okay, so there you have it. Simplifying some complex fractions. Okay, so time for the practice problems. Have fun.